Today, Dion is going to guide us through the huge release, new release of the BlenderBIM Add-on, the very first one from 2021. Hello, Dion. What's happening here, man?
Hey, Petru. Yeah, this is a really huge release, and it has a big impact on what BlenderBIM can do today and what it will be able to do in the future. And you're right, it's the first release of the year, and we usually try and do a release at least once a month, so we made it on the very last day. And essentially, almost everything under the hood has changed in this release. All the code has been, from the past year of development, has basically been rewritten in about a month. So with a lot of big changes, there are probably a lot of issues that come with it. So a word of warning for people who are trying out this release that it could have issues. Well, it must have issues. But that said, if it does work, there are some really interesting aspects that I think we can discuss today.
Yeah, that sounds very good. Let's go through the most important features.
Yeah. So I guess as a user who is not too worried about under the hood or technical or code or all that type of stuff, there are a few things which make this release really, really exciting. And all of them are written down in the release notes, which I'm sure a link will be provided, and you can read in detail. And you can also see a big list of all of the individual tiny changes that were made. But at the very top, you'll see a little summary of what the biggest impact is going to be. So I guess we'll just go through one by one, and I'll elaborate a little bit more compared to what I've written down. So the first one is pretty self-explanatory. It's zero data loss during import or export. So right now, almost everybody's experience with openBIM revolves around using an import or export feature in another application. So they would model it in their application, and sometimes people call this the native model. And then they would press the import button or the export button, and that would convert to or from an IFC to or from the native model. And there are lots of problems with that, because the whole point of IFC and international standards is for us to collaborate seamlessly with one another. But you can't really do that if you have to rely on an import-export, because every time you rely on an import-export, there is a translation or mapping that happens between your native model and the IFC model. And I think everybody who has done this process is very familiar that you do get a huge amount of data loss whenever you import or you export. And this is a significant amount of data loss. And it's not just data loss. There's also a lack of understanding of where the data is stored. So let's say you have some BIM data stored in your model, and when you press export, you're not even sure if it's there. Like sometimes you have to double check whether the export did it correctly, and sometimes it might turn up in a different location that you didn't expect, or there might be data in there that you had no idea existed and was just automatically generated. So users have extremely little control over their BIM data, and that is against the whole concept of collaboration and interoperability. What we need are applications where the user can trust their BIM data. And the only way to do that is to treat IFC as a native BIM format. And that's exactly what the BlenderBIM add-on does. So now with the BlenderBIM add-on, when you are editing your BIM model, you are editing IFC directly. You are not relying on an import or an export translation. And the result of that is that there's now zero data loss. You don't need to worry about certifications or whether somebody has tested the import or export, or whether there are workarounds for each vendor. All of that goes away, because what you see is truly what your BIM data is. There is zero data loss.
But is this any different than it used to be the previous version of BlenderBIM, or this has been the whole time the case?
Sort of. So in the previous version of BlenderBIM, there was still a translation. However, the translation was quite minimal because the way the system worked was that it took the IFC structure and it copied it into Blender, and that's very close to having zero data loss, but it's not zero data loss. So for example, things which he hadn't implemented it, so for example a lot of MEP type features which have not yet been built into BlenderBIM, that data would be lost. So over time, BlenderBIM has had more and more support for the spec, but it never had 100%, and zero applications out there have 100% support for the spec. That's just a fact. And so everybody has data loss. BlenderBIM tends to have less data loss due to the amount of support it has, and also the fact that there's not much translation. Because other applications, they have had decades of history behind them where they would be where the way you do things in Revit, or the way that you do things in ArchiCAD, the way you do things in TechLab, that's the way you do things. And then when you export or import into IFC, somebody has to decide, how do you translate this way of doing it to the IFC way of doing it? Whereas BlenderBIM never really had that translation. The way it was designed in Blender was from the beginning very, very close. But that's the distinction here. It was very, very close, but not perfect. But now that's what this release does. It makes the jump from very close to perfect. So yeah, I guess that you don't need to worry about it anymore whenever you
Congratulations, man. Then this is really huge. This is really, really huge.
Correct. It means that users can trust their BIM data. Because in the past, people would treat IFCs as a transfer format almost, or a reference, right? You export it, but that's it. It's a dead end. Nobody touches it anymore. Anytime you want to update data, you have to update the original native and then rely on another translation. And as a result of that, you never really had interoperability. It was always a dead end, between project phases or when exchanging stakeholders. People would redo the same work again and again and again simply because they couldn't take advantage of all that IFC data. But this changes things. Finally, there is an application, and BlenderBIM's not the first one. We have to give credit where credit's due. I believe this approach has been implemented before, but it's extremely rare, and I can't name a commonly used application. But if people watching this do know, I'd love for them to leave a comment on other applications which do use this approach too. But finally, we now have a slightly more accessible application where everybody can say, yeah, we can now, between project phases, between exchanging stakeholders, keep this IFC data and progressively, incrementally add more and more, make it richer, make it cleaner, instead of kind of just saying, yeah, here's a file, it kind of exported, you can look at it, don't fully trust it, and you kind of just ignore it after a while.
That's very important. That's very important. And I had 2 days ago, there was somebody, a civil engineer from Germany, who we talked about a little bit during my daily live streaming. He had this challenge. He needed to export from Allplan and get it to a structural analysis software, and he needed to export from Allplan to after that import in Tekla, and after that to export to that software to get in the right place. And God knows only what happens behind the scenes. You don't know anything, right? So it's very, very nice that now we have a tool that you can audit your IFC file and trust in it, that this is how it is, and you start understanding. You can see how you can understand maybe better how the other application is exporting the IFC file, or I don't know. What do you think?
Absolutely. Previously, people almost had to learn all of the quirks that happen during translation and the workarounds. But it shouldn't be like that. That's not how interoperability is meant to be. And this really changes the game. And we so far we're talking about current projects, but this also applies to historic projects, right? All this heap of digital data that people are creating on every single project, at the end of the day, you always get two files. You get the IFC and you get your native one, and the native one expires. Over time, it sort of just fades away, and you're only left with the IFC, but people think that you can't do much with the IFC. But so for all your historic projects, you now have a whole bunch of IFC files because the native ones are long gone. And well, this now offers you a tool that people can use to maintain and upgrade and their digital digital real estate portfolio, essentially. So all historic projects can now be maintained across the lifetime of the building.
And it costs zilch. It doesn't cost anything. It's free, open source.
Correct. It's all free and open source.
Oh my God! Thank you, man. Thank you for doing such a great work. This is amazing. I'm mind blown. It's amazing. Regarding the native format of the files, of the IFC files, right? Like the BlenderBIM add-on is doing this, and you mentioned that the other applications are just translating, or they try to spit out, depending how they understand, they should spit out the file, right? Would be there any things that they can do better? Like, do you see, would be possible that the other applications can get it to the same level as BlenderBIM to have the capability to use it in a native way without doing this distorted import-export kind of?
Yeah, I mean, they could use the previous approach that BlenderBIM used, which was to just build more and more support of the spec and improve the mapping until and the user experience around that mapping. But that's a really, really hard task, and almost a never-ending task. So I'm not entirely convinced that that's the best way to go, but absolutely, that is definitely an option that people can take.
No, but I understand they have interests, but if they want to comply with building smart and with everything, but at the end of the day, if they would, let's say, if they would have the willing to do that, would that be possible from an implementation point of view?
Everybody can do what I have done here with BlenderBIM.
Okay.
Absolutely, everybody can do that. There's no technical reason why other people cannot take the same approach. Yeah, I guess it's just a matter of willpower.
Yeah, and if they do that, what they lose doing that is that after that, each application would differentiate itself from others, just how they have the tools built inside, how you build, how you work with one or another, right? But they are afraid to lose the leverage they have inside their application. Or what reasons do you think they have that they don't want to open more?
Well, let me try to clarify a misunderstanding here.
Okay.
This is just because IFC can be treated as a native format doesn't mean that makes applications useless, like every application becomes the same. So for example, let's say I'm editing a brand new IFC file. Now, in Blender, I can apply something called a modifier. And this is if somebody has done visual programming before, you might understand this concept as a bit. So let's say I have a whole bunch of cubes which are being arrayed, something like that, let's say. And now let's say I want to do a neat little trick here, and I want to go and apply this empty object as an offset. So just a moment, let's do something interesting here. All right, so this is a crazy shape that I created in about, I don't know, whatever, under a minute. And
20 seconds.
Okay, great. we can fact check that. So IFC does not have the capability to store this particular type of parametric transformation within the IFC data right now. Maybe in the future it might, but right now it does not. Therefore, This is one particular scenario in that having a native application, which augments or complements the IFC functions with more features on top, can be useful. Whereas the base BIM data is still a stable foundation that everybody can trust. Whereas there are sort of I guess user level extensions or application level extensions that do particularly neat tricks that we might need on complex tasks. Whereas all the basic needs, like, a wall is a wall is a wall, most applications, a wall is a wall,
Yeah.
all that becomes part of the basic package. And we're no longer, we're no longer stuck on one application simply because we have to deal, because of, everybody wants to use those walls. Now we can switch between applications, and in fact, I can use Blender to model aspects which do this type of cool thing that I could do in 20 seconds, and then I would switch to FreeCAD, which would then go use its particular strength in a parametric hierarchy of modifications, and then I could switch again to Sverjak to do visual node programming, or I could then switch to another application which offers a really awesome interface for costing or scheduling, and each one of these can specialize on different aspects and add little bits, their little flavor of usability improvement or even cool tricks, just like the one I have right here. And so it doesn't remove the need for native applications. In fact, this just makes it better, because now I can actually build half my model in this app and then switch over to another app and then switch over to a third app and have people from 10 apps all using different applications which use the best tool for the job.
So then what is the reason then? They just don't want to make the industry more cooperative, or what is the reason if losing competitive advantage is not?
I don't know. We'll let you, yeah.
We can speculate.
Yeah, we can speculate. Yeah. I think we've made the point. Zero data loss. That's the words you need to remember. So I guess one of the implications of treating IFC as a native format is that we get much faster import times. So this is great, because importing can be very painful in some software, and so it's really important for people to be able to import quickly if they want to start treating IFC not just as if they want to treat it as the native model. So BlenderBIM now has twice as fast import times on average. It kind of depends. Sometimes it's faster, sometimes it's slower. Sometimes you get 70%, sometimes you get 30%. So it really varies depending on what the content of the file is. And you can also see that it may also not correlate to file size. So for example, the 64 megabyte architecture file actually imports way faster than the 51 megabyte structural file in this one particular scenario. That's not a general statement. It's highly specific to what's in the file. And I guess this will come more when people understand about what is stored in their IFC file. Again, with this, when people can say, hey, hold on, why is my file so big or so small? How is it storing all this geometry or data? I guess one also important thing is that the last release did have a bug in it where certain files, files which use a feature of IFC known as presentation layers, basically a CAD layer. So there was a bug in the last release where those files could take very long time to import. That's been fixed. And so if you were affected by that bug, then it would actually get maybe even 4 times faster to import. So basically much faster import time. And also your Blender will use less of your system resources. So Blender is also already pretty good with dealing with huge files especially on low-end hardware. But I guess this just makes it better again.
Yeah, very nice.
Okay, well, I'll do export times because this is a very simple one. Basically, export times are now practically instant.
But
so
export what?
It's called export because I haven't. I guess maybe I should change the name to save. Yeah, but I mean, no, I'll keep it. I'll keep the name as export. I didn't think too much about that because don't forget, IFC is not a format, right? There's many possible formats. So
yeah, exactly.
I guess what the export does is embedded in a particular format that you've decided. So the export could be writing it to a IFC file or IFC JSON file, or it could be publishing it to a shared central server or something like that that you're all collaborating on, or something like that. So I guess what this means is that in the past, so if I'll do a quick demo here. If I just go and import, this test file. So there it is. That was twice as fast, by the way. So now if I press, if I press the export button and I go type in test, done. It's already exported. Just like there's no progress, nothing. It's already done. It's practically instant. And to give you and obviously nothing is instant, but to give you an idea of just how fast it is, if you are saving out a 350 megabyte file on my computer, that will take about 20 seconds. And all that depends on is your, and really the factor that depends on is if you are exporting to a .ifc file, it would be how fast your computer can write a file to your disk. So that's the limiting factor. There's no processing happening whatsoever because it's already pre-processed. It's just how fast can it spit it out.
Impressive, very impressive. Great work again. Great work.
Because that's usually a really painful thing, and that makes people not want to create IFCs because you can take half a day or even a whole day on a really complicated project just exporting. It's such a waste of time. In the process of rewriting everything, there's been a whole bunch of really cool new user interface improvements as well. So now everything is automatically adapted to your IFC version, and the UI you'll find is generally a lot cleaner. There's a lot less clutter in the UI. All that's been cleaned up, and now there's sort of a standardized user experience across different modules. So previously, when it was first built, it kind of just evolved over time, but I've taken a fresh look at that, and now every single module works in a more or less consistent way. So that's really exciting for users because they just look at a module and it's pretty obvious how to use. And I guess one of the biggest improvements is that it understands the IFC version that you're using. So for example, if I click on this object and I see it has a predefined type of floor and I press the edit button, now you can see that I can just click on the drop down of floor and it will show me what options are available. And this is specific to the IFC version. So in some applications, you don't know any of this, right? You'll have to actually look up the spec, and it's really not user-friendly. So this allows you to do it. But also this will adapt based on your IFC version. So I guess the best way to explain that is if I open up a brand new BlenderBIM and we compare the two. So this over here is an IFC 2x3 project. So let's say I'm creating a brand new object, and I can select what type of IFC element it is. And you can see this is what's available to me. And this is what's available in IFC 2x3. But then if I switch to this one and I create a new project that is IFC 4, not IFC 2x3, and now I want to assign a class, you can see all this available to me. And just things like that make the user realize, okay, this is the impact. This is of using a particular IFC version. Here are the options that are really available to me. In the past, BlenderBIM didn't have that. In the past, BlenderBIM always assumed you were going to work with IFC 4, but if you really, really wanted to, you could use 2x3, but it would always default to 4.
And it was cumbersome. Yeah.
Yeah, and this would confuse a lot of users because sometimes they would, I guess, upgrade their file without realizing, and
Uh-huh.
or downgrade if they were trying to fix it. And this creates a lot of issues. But now this guides the user on what's possible. So I guess for those who haven't seen it before, this is the difference between IFC4 and IFC 2x3. So if you haven't switched yet, please do, because that's all of the information that you are missing out on.
Huge. Wow. Yeah.
And it's the same when filling out property sets. You know, you don't need to map it and read up the spec. So for example, if I'm editing the wall comment, I can just press edit and it knows, you know, the status will set it to existing. Let's say it's combustible, and let's say this is a load bearing wall. So, and there's number sliders as well. And then I can just press the OK button. And I guess one of the things this also highlights is whether or not a value is null or not. So this is a concept that I think a lot of BIM applications have missed. How do you know whether the property exists because the computer has generated it with a default value or a blank value, or the user has actually explicitly looked at it and assigned it a blank value, or is going to fill it out, or has to fill it out? And there is no differentiation between this usually in BIM programs. Whereas now I can see that previously is external was unchecked, but it truly was unchecked. This filled in circle means that was a property that the user or application had explicitly set that to be unchecked. I know it's not that the user just forgot about it. If this were blue and empty, this would mean that the user has not specified it at all. It's not true, it's not false, it's really unspecified. So the ability to know whether or not something is specified, so I can say, okay, now I'm specifying this, and we'll say, all right, there we go. Now it truly is specified.
You must click on that dot as well.
That's a bit annoying. Tell you what, we'll fix that in the next release.
Okay. Yeah, it should be automatically, right? When you check that box, it should be activated.
Correct. We'll fix that. We'll make it so that once you toggle something, it auto updates.
So it's so nice to hear that.
Oh, well. But there you go. I guess this is just one of the usability improvements that people can expect. All of what I described so far leads to this big change, which is what we call partial IFC editing. So the idea is that IFCs represent a huge amount of data, and that data set is only set to grow. People have this misconception that you have to process the entire IFC file, and it becomes very big and cumbersome to work with. But this approach, what it allows you to do is only edit parts of the IFC file. So for example, let's say this were a huge model. So let's just start again from scratch. And I'm going to import that model. But let's say it's ridiculously huge. And let's say I only want to do an environmental simulate or just like a basic massing model. So I'm only after the walls and the slab objects. So we'll press import. So now I have only walls and slabs. I got nothing else. So that import was faster than the previous one, by the way, but it's hard to notice. And now I can just edit those files and save those out back to the original IFC. And all of the remaining objects that I didn't import have not been damaged in any way. They're still there. So that allows people to edit only portions of an IFC. And BlenderBIM keeps track of who's edited what. And this is unfortunately, there isn't a pretty interface built for this yet, so I'll show you the scary developer interface. But for example, let's say I'm editing this wall and I change the name from this ridiculous thing to, fancy wall, to another ridiculous thing. Now I can see that this wall actually has
a name
been modified. It's been modified by a particular person and this particular application. So it keeps track of who's modified what. Whereas this wall, you can see that there's no change being made. So this might seem not too crazy useful for users just yet, but I think developers might see a lot of potential with this. And one of the things it will allow us to do is to have multiple users editing portions of IFCs simultaneously across different applications in a sort of multi-user collaboration environment. So that will come, not yet, but that's one of the things that this type of partial editing enables. And hopefully it also helps people question that IFC is not this huge monolithic thing. It actually is quite delineated. So you can edit just attributes without touching anything else, or just construction type.
Let me ask you something. So let's say that, for example, you are working in another application, right? In another, like Revit, and you want to fix some things that you cannot fix in Revit. Can you take it a small part of it in BlenderBIM, fix what you want to fix from IFC perspective to export it, right? And merge it back in Revit? Would that make any sense?
Yes, correct. You absolutely could. I mean, Revit couldn't import it probably without a lot of data loss because of the first issue we talked about. But what you could do is that you could take something exported out of Revit and use Blender just to modify a portion of it that you know needs fixing up for whatever reason, and then save that back out. And then it now has a full history that actually this is 100%. This is a 99% Revit file, except for this 1%, which was modified by this application.
And let's say like you don't go back to Revit, but can you use only that modified part with the other part of that comes from Revit in another application where you put together the entire model, for example, like Solibre that is reading an IFC files, right? Could you do that? Would you see the changes in this kind of softwares, or?
Actually, I think you're thinking that this splits up the file into the big chunk and then the little bit that you extract out. But it's not actually extracting it out.
No, it's the same file.
It's still part of the big file.
Okay.
It's the same thing. Yeah, it's just modifying a portion of it.
But if you have the file originating from two different sources, you have the original file from Revit, right?
Yep.
And you cannot update it in Revit. You do it in BlenderBIM.
Well, if you wanted to update it in Revit, you would have to modify your native Revit element or whatever setting.
Yeah.
Then you would need to do a full export process all over again, and that would process everything and all of the stuff that comes with that. Whereas with this approach, you could take the existing export, bring it into BlenderBIM, or just bring a portion of it into BlenderBIM, tweak it, and then save out the fully changed file. It's not two files; it's still one file that's changed.
Yeah. Okay. I understand. But then from Revit, would be possible to export only part of the file to put everything together, so you don't have the same elements overlapping when you put everything together?
In theory, you could do that. In theory, however, that relies on applications properly implementing things like tracking who changed what, or whether it's or having consistent IDs on particular types of objects or relationships. Unfortunately, I don't think that's currently possible with Revit, but with another application, absolutely, that's probably something we should definitely do a session on next time when we have a technical demo.
Yeah, but you know what? I'm thinking like from an ideal workflow perspective, what would be the best workflow? So because BlenderBIM does all these things so well, would be good like to do everything you can do. Like if you're using Revit, like let's say you use at work, you have no choice. You will use Revit, and to do all this stuff related to IFC, to just do it in BlenderBIM would make more sense? Or will you just use BlenderBIM to audit? You do everything in Revit, whatever you can, the maximum you can do, you export it and use BlenderBIM to audit the IFC file, and after that to fix everything you need to fix, and use it after that for multidisciplinary or federated models.
What was the question? I didn't quite get that.
Regarding the workflow, what would be the best workflow? Like, how would you do it if you need to use Revit or Tekla or Alplan or ArchiCAD?
Well, if you need to use it, then you don't have a choice, right? You have to create your IFC from your native app.
Yes, I mean, how do you take both things from both worlds? How do you take the best from BlenderBIM with the best from these tools to make it to the most streamlined workflow?
I think you change things in your proprietary application, change things which are easy to change to get the IFC as a base state as good as possible. And then the things which are too tricky to change or simply cannot be changed, then you'll resort to BlenderBIM. So I guess it's a bit like, when people do photo editing, right? Yeah. You always try to get the best base photo you can with your camera, and then later on you bring it into your editing tool and you add decoration on top.
Yeah, that makes sense. Okay.
But I could be wrong. That's just me. Maybe somebody else, has a cool thing, and if you do, share it.
Yeah,
let's work it out.
Share it, of course.
I don't know how many people use BCF in Blender, probably not that many. And the reason is because previously in BlenderBIM, BCF was basically a read-only system. So you look at all your issues, but that was it. You just look at them, which is not very exciting. So BlenderBIM has now got a brand new BCF system. And now basically you can do everything that you would expect. There's nothing much more to say other than that. You can write comments, edit labels, and assign related topics and all that. You'll find it here in the BCF project panel, and you'll just load in your project, or you can create a brand new project. So there's no real interesting. I mean, this is just the things that you would expect from your issue management software. You would say, okay, fix wall or something like that.
But how would you work together with other people? So this is just, you need to share the file, right? You save it in the file and you need to share the file. Is there any way you can make it interactive, the cooperation between more people on the same project?
So currently we're implementing BCF XML, which means that you're absolutely right. You need to save the BCF file and share that with different people. But part of the reason of rebuilding this BCF system is to allow support for what's called the BCF API. And we don't have that yet, but that's exactly what it does. It allows you to connect to a cloud or a server and access your issues from there. So what this would allow people to do is that, let's say you have some cloud platform that your BIM model is on, but Blender offers much nicer environment for looking around your model and investigating things. Then you would open up Blender, tell it to connect to your API, and view the issues. But right now, obviously, that's not done yet, but it will be. But I guess one of the biggest improvements that, as a side effect of that, is that IFC Clash now exports to BCF. So there is a clash detection feature in BlenderBIM over here, so clash sets. So you can create clash sets, and you can add different clash sources from one or two or more files, or within the same file, or whatever configuration you want.
Let me ask you something regarding this add clash sources. Can you, for example, set their import or use their clash sets from Solibri or other softwares? Or you need to create them manually inside here?
Well, I am not aware of a standardized way of describing clash sets. So right now, you can only, just like any other application, you can define it within the application, and then you can import or export, which you can see the buttons here, that particular clash set within the application. But I'm not aware of a standard of sharing clash sets, and that's a real shame because there really should be. That would be a simple thing to do. And yeah, I guess if somebody, I haven't looked too much at those formats, but if somebody knows those formats a bit more and can build a feature that can read them, please do. But I guess one of the things that we'd really like in clash set definitions is for it to be tied to IFC so that you can actually use them. So for example, let's say within Navisworks, I would assume that their clash set system is generic. It doesn't necessarily apply just to IFC. So queries that I could describe in IFC using an IFC query language, which BlenderBIM supports, cannot be shared simply because they don't treat IFC as something that is the de facto way that BIM models, or is the standard for how BIM models should be shared. Anyway, that's a very long-winded way of saying that if somebody knows those formats and will build a connector, please do. I'm not aware of a standard, but if you are looking for one, well, why not use this one? Because this is an open standard. The clash set definition is defined in just JSON, so anybody can work it out. So if I go and press export, you can see that clash set definition, clash set, is just a pure JSON file, which you can see there. So it's real simple to use.
Okay.
But I guess what I was saying at the beginning is that in the past, clash sets, the collision detection features in BlenderBIM would only export out the results within Blender itself in a really not very user-friendly way, as well as export out to a JSON file. And that's fine if you're a really technical person and you can understand that, but it's not fine for users who want to see, who want to bring those results in BCF and maybe upload it to the cloud or view it on another dedicated issue management platform. So the really exciting bit is that now we can do that. So yeah, it's a step in the right direction.
Yeah, amazing. Great work again.
Finally, there's this one here, which is maybe we won't spend too much time on, because in a future release, when drawings have a lot more improvements, we'll spend more time on it then. But we are starting more on a system of 3D annotations. So the ability to create annotations within your viewport and understand what's going on. So in the past, for example, if I create a drawing, and I just clean that up. So let's have my drawing here, and we'll decrease the size of that drawing and shift it around here. And in the past, this is how you would create dimensions, and that's really, well, poor for the user experience. But now we have all of this stuff, so I'll just make that black, and you can see how now it becomes a lot more user-friendly. They can see what's going on when they're measuring things, and I guess that's part of making a proper full annotation environment, is to have all of these indicators. So for example, if I then put a plan level on somewhere, for example, like that, yep, that's RL0. And of course it will show in 3D as well. So this is all just kind of stuff. So this was the old system. If I just turned that off, which is not very good, and it would generate it when you create the drawing. But the new system is, well, a lot better in that regard. You can actually see what you're doing before you finally generate your drawing.
Yeah.
There you go. That's your drawing.
Okay, interesting. That's good. Looking good.
Yeah, but there's still a huge amount of work to be done on this, but it is a start to provide this sort of interactive 3D annotation. But it'll get better and better.
Yeah.